Good evening, everyone. My name is Cooper Wiegand. I'm a doctoral candidate here at Dakota State University, and this week we are bringing you guys a new tool as part of our security tool development course. This tool is called Sonistream. It's a steganography tool. It's used primarily for making CTF challenges. Steganography is the art of hiding data inside media, primarily images historically. So maybe you get an image, it's got some secret codes in it or whatever. This tool is for embedding data into audio files, so music and things like that. For our music, we are going to be using this Doing Damage by Dollshade. It's from Bensound. It's a free to use. You just got to do attribution. You guys will probably hear it playing in the background of the YouTube video. So let me show you guys how this works. So for CTFs, if you don't know, typically you're given some sort of file. In this case, it's going to be an audio file. And your goal is to recover, a flag or some piece of data or something like that to progress through. The purpose of these challenges is to get you thinking about out-of-the-box ways to hide or transmit data to improve your cyber skills. So they're popular at conferences and their CTF events pretty much every weekend, things like that, competitions and such. So this is a tool for building those sorts of challenges. So let's go ahead and download it. We'll look at the quick start here. We'll get this downloaded. We'll go ahead and build it, and then I'll kind of show you guys how it works. So first things first, make sure you have Python. You're going to need a library called Librosa. And down here in the references section, I've included the Librosa example gallery, as well as some things with CyberChef and how to use Audacity and this noise canceling headphones thing that we're going to look at in a second here. But yeah, go ahead and download this. And then you're going to modify some of these parameters. So let's go ahead and take a look at that. All right, so we have our repo downloaded here. Let's go ahead and open up build.py. And we'll hop down here into these parameters. So first thing is we need a template file, and this is the audio that we want to encode our data over. So I downloaded Doing Damage WAV, and I've included it for you guys in the repo. You can use MP3, whatever you want for audio files, but I prefer WAV. Then we have our plain text, so this is the data that we're going to be encoding for our contenders. So in this case, it's going to be Flag with Go Trojans, who is the mascot of Dakota State University. Then we've got our start second, so we're going to wait 10 seconds before we start encoding data. Our amp factor is 1. In a later example, I'll up this to 10 so you guys can see kind of how that affects the challenge. But for kind of the incognito, stealth mode, we're going to go with an amp factor of 1. And then here you can see that it's going to build a challenge.wav. We can give that file to our contenders, and then we'll have sanity check so that we can check and make sure everything is encoded properly. So let's go ahead and run this, and we will take a look at some of the outputs here. So Python build. Here we have some hex data and our Morse data. I'll get more on that in a second. But now we have our challenge and our sanity check. So let's hop back to the README real quick. Let's see, we covered this, modifying parameters. We built it. Before I kind of dive in, let's do a quick section on kind of how it works and what we're trying to accomplish here. So I kind of have how it works here, but I've also included a link to this noise canceling headphones kind of write-up. And this guy does a great job explaining how this works. But essentially, when we have two audio waves, so the principle that we're playing on here is the same one that's used in noise canceling headphones, but we're modifying it with bumps to encode data, which will make more sense in a second. But what you need to know is that when you have two signals, so we have our source here, right? They're moving through. Actually, we'll just kind of look at the destination section here, but these two, when you combine them together, the positive portion here, the up portion, is going to combine with this one to create a more drastic wave, if that makes sense. So see how this one is essentially amplified or whatever. It's a constructive wave. So this bump and this bump are adding together to get this, and this one and this one are adding together to get this one. Okay. And I kind of have a really basic example here, 2 and 3 equals 5, but conversely, 2 and -2, we can actually cancel out some waves here. So let's take another look. So when you have a wave that is just like our previous example, and then another wave that is the inverted wave, What happens is that this bump, I'm sorry, the amplitude of this wave here cancels out with this wave and you get a flat line. And then this one cancels out with this one, so you continue. So now you get silence. Okay, and that's kind of how noise canceling headphones work. All right, so now that we understand how waves cancel out, let's go ahead and look at that in Audacity. Okay, so as a reminder here, we already ran our builder, and what we're hoping to do is encode this flag into an audio file, and it generated these two files. It generated challenge and sanity check. So first things first, we will import our, we'll call it the origin signal, right? The unaltered one, the one that we got off the internet. So let's grab our doing damage here, and you can play this. And here, when we kind of zoom in here, and I'm holding Command on Mac or Control on Windows and then scrolling, but you can see these waves. They're very similar to these waves, right? They go up and down, and that's kind of how the audio looks when you look at the waveform. Okay, and now we're going to import our challenge file. And when we play these together, right now the waves match, right? As this one goes up, this one goes up, okay? And so what we're going to do here, we're going to go to Effect, Special, and Invert. And now these waves are working against each other, see? So as this one goes up, this one goes down. And based off the principle that we kind of just went through here, what we're doing is we're essentially creating silence. So as a contender, you would have this bottom one. Your first step would be, hey, what song is this, right? Oh, it's doing damage. You know, I did some OSINT, I figured out what it was. I went and I got this file off the internet. So now I'm like, okay, is there any data encoded into the file? So we're going to invert it, and then we're going to play these against each other. And what you'll notice, you hear that? Nothing. It's silent, right? Now remember, we started encoding data around the 10. So in a second here, see how the audio bar is moving just slightly up and down? What it's actually doing, and if we export this audio, let's go ahead and say this is the sum. Mono, highest sample rate we've got, entire project. So we'll go ahead and export this. And now when we import our audio, remember the waves are canceling out here, right? That's the goal of the challenge. Just like knowing that you need to cancel it out to see the resulting underlying data. Look at that. Now we've got little bits of Morse code throwing out. All the other little bits of the wave, you know, this little arch right here is canceling out that one, right? So all you're left with is the Morse. And then from here you can decode it and, you know, go about your way. So if you're interested in that process, take a look down here at the how to solve. But essentially in CyberChef here, what we're doing is you go from Morse, it gives you some hex data, and then you go hex to ASCII. And we do that transition with hex mostly because we want to support like capitalization and curly brackets, and you know, we don't want to be limited by Morse can really only handle like some maybe like a character or two and some uppercase. So yeah, pretty basic tool. There's not too much to it. We'll take a quick look at the code here. As I mentioned before, these are your configuration parameters. We have our Morse dictionary. Here we have our adjust volume, and what we're doing is, because that's kind of what we're doing here, right? Is we're adjusting the volume. So like for instance, if we take this amp factor and we crank it up to 10 instead of 1, let's go ahead and rerun. Okay. Now when we import it, because remember we cranked it all the way up to 10, when we import the challenge file, let's also import our sanity check. And you'll see, even if you didn't have this origin file, you can kind of make out these dots and dashes, right? Because we are really cranking the waveform here. And actually, when we're hopping through this section, so we're distorting it beyond what would be considered like covert, right? The human ear can pick it up. Doing something like 1 is kind of like a happy medium of like, you really can't tell in the waveform that there's anything wrong, But when you invert it, as long as you're still lossless and you're comparing with the correct audio file and whatever, the Morse will just pop out. Okay, so what we're doing, I know that's kind of a tangent, but adjust volume, what we're doing is we're actually modifying that waveform ever so slightly. So in here, compared to this one, we're just cranking it up by a factor of 10. Okay. Let's see here. We've got our auto overlay. This is more of a, this is for our sanity check. We have our trim audio. For these challenges, we don't always use the entire file. Songs can be quite long. We only need a clip of it. Yeah, and then we have our basic thing here. So load it in with Labrosa, start it up, encode everything, adjust the volume based on our timing that we defined for Morse, and then we spit out our files. So pretty simple tool, straightforward, kind of a different sort of steganography challenge. In terms of future work and things, I don't really think there's too much to do in terms of this. It's really it's kind of like a one and done tool to build these challenges. I suppose you can invert it. Maybe you get an audio file and you run some sort of analytics on it to try to extract data, even if you don't have the source file. Yeah, in terms of building the challenges, is really all you need. The nice thing is that your contenders, they don't have to have a script to solve it, right? Like it's definitely, I mean, you saw us solve it in Audacity here. You take your 2, you invert it, export, re-import, and then you just translate the Morse. So pretty straightforward. If you guys have any suggestions or feedback or things you want to see, feel free to let me know. But other than that, yeah, enjoy. Maybe you'll see one of these challenges if you attend a lot of conferences and stuff this year. I think we might use it. But yeah, otherwise, you guys have a great night.